Well, hello again. It's time for Chemistry A, Unit 2, the periodic table. We are talking about our Day 2 notes, so let's get started. We're first going to talk about a gentleman who gets credit for being the first one to come up with a usable periodic table. And what he did is he organized that periodic table by atomic mass, by the mass of the atoms, and he came up with his own table, and we'll take a look at that here in a few minutes. So Mendeleev is the first guy to get credit for publishing the first usable periodic table. Now, his periodic table was his goal of his periodic table was to show the relationships amongst more than 60 elements. He arranged these elements into groups based on a set of repeating properties. Now, what is a property? Don't forget, a property is a characteristic, if you will, of an object. So let's say a property of gold is that it's metallic, so it has the ability to conduct electricity. It also is malleable, ductile, and those kinds of things. So that's what a property is. It's a characteristic. Okay. Now Mendeleev arranged, like I said before, he arranged the elements in the order of increasing atomic mass. Now his version was incorrect because he used mass to arrange it. Now when I say it's incorrect, later on other scientists came through and came up with their own periodic table, and they arranged it by something else, and that proved Mendeleev's idea of arranging it by atomic mass incorrect. Here is what his original table looked like. Okay, and he had these all arranged by atomic mass. As you can see, he had lithium right here where the mouse is. You can see that. Potassium, rubidium, cesium, all right. Beryllium, he had boron, he had carbon, and these are all by mass now. See, carbon's mass is about 12. Nitrogen, oxygen, etc. So this is what his table looked like, which proved to be incorrect. He had more than 60 elements, but one of the things that he said was that there would be more elements out there, and they would fill in these spots, these dashes on the table where there is nothing. He said, we will find things that will fit into there, and of course he was correct. Now the modern periodic table is set up much the same way, except it uses one major difference in how it arranges it, and it arranges it by increasing atomic number. Now remember, that's the number of protons in the atom. Our modern periodic table has 7 rows. Each of those rows are called a period. Whoa, time out, time out. When I look at my periodic table, Mr. Pack, I see 9 rows. Those 2 at the bottom, if you look really carefully, those 2 at the bottom actually are pulled out from the last 2 rows of the periodic table. And it makes it look like there's 9, but there's really only 7. Now each row also equals the principal energy level in an atom. Elements within these columns, elements within columns are called groups, and those elements all up and down in that group have similar properties. So remember, groups run up and down like columns. Okay? The properties of the elements will change within a period as you move from left to right. So as you move from left to right, each element will change its properties just a little bit. All right. Now, there are 3 main classes of elements. 3 main classes of elements. The first main class are the metals. They are 80% of the elements that we can find. Their properties include, number 1, they are good conductors of heat and electric current. That's why we use copper for our wiring, and that's why we use iron for our cooking utensils, cookingware, because they conduct heat and electricity very well. They have a high luster and sheen if freshly cut. They are solid at room temperatures, except for mercury. Mercury is liquid at room temperature. Many of these are ductile, meaning that they can be drawn into wires, made into wires. That's how they make them. They draw them, they pull them into wires. And most of them are malleable, meaning they can be hammered into thin sheets. And here are the metals, as you can see, 80%. All this group in here are all metals, left of what we call the staircase, the black line. Okay? And that earlier that I told you about, those 2 rows that looked like, no, there's 9. Here's there's 7 periods. And then lanthanides and actinides, those 2 fit right in there. They're pulled out so that this chart can be usable. Otherwise, this 6th and 7th row would go way out here on the outside and it's not usable. So that's the first class, first main category. The second main category are the nonmetals. As you can see, a much smaller group, as shown in our picture here. They are the upper right corner of the periodic table of elements. Their properties include a greater variation in physical characteristics or properties compared with the metals. They are gases at room temperature. Few of them are solids. They tend to have properties that are opposite of metals. They are poor conductors of heat and current, and they tend to be brittle, meaning they shatter when they are hit. Of course, not all of them are poor conductors. We know one, this one over here, this lone one that's over here by the metals, of course, that's hydrogen. And we know that is an excellent conductor of electricity because of the hydrogen that was inside the Hindenburg, and when that caught on fire, it was caused by the flammability of hydrogen. So, and of course, we know oxygen is flammable as well, but in general, they are not good conductors of heat and current. Okay, and that's the second one. And then the third one are the metalloids. Those are the stair-step elements, as you can see right here on the diagram. They kind of look like stair steps. That's why they call them stair steps. The properties are similar in general to metals and nonmetals. Under some conditions, they will behave like a metal. Under other conditions, nope, they'll behave like a nonmetal. So those are the metalloids.